In this lesson, we're going to talk about midpoint and distance. Midpoint is a point on the segment right here that cuts it in half. So it means that these two sides are congruent or equal. So if that's the midpoint, then this side is equal to this side. So you could say M is the midpoint of AB. Right, so the line segment, put a little line over it. And that lets us know that AM is equal to MB. Right? So that's the midpoint. Midpoint just lets you know, oh, that's in the middle of the segment. So that means that this side must be equal to this side. Bisects is a little definition. If you bisect something, you cut it in half. Right? Bi means two. So when you bisect something, you cut it in half into two equal portions. So right here we have a segment bisector. So that means that we're going to bisect the segment or cut it in half, right, into two equal portions. So a segment bisector is just any segment, ray, line, or even plane that intersects a segment at a midpoint. So if we cut it through the midpoint, we're a segment bisector. So we could say here, M is the midpoint again of AB. Then we could say MN, now it's a line, so put a little line marks there, intersects AB at point M. And we could say AM is equal to MB. So this side's congruent to this side. Okay. Now let's talk about finding the midpoint. Now that we know what a midpoint is, how it works, let's actually talk about finding a midpoint. So if I give you 2 points, how are we going to find the midpoint? Well, the formula says you add up the x's and divide by 2, and you add the y's and divide by 2, which makes sense. The midpoint's just the middle. It's just, I always like to think about it as the average of 2 points. If you already want to find the average of the middle of two things, you just add them up and divide by 2. So that's how you find the midpoint. Add them up and divide by 2. So let's do an example or two. Right, so find the coordinates of the midpoint of AB if A is -1, -8. So -1, -8 is like down here. There's my A. And B is 5, -2. So right there. Right, the midpoint, if I look at these two, and the midpoint should be like around here, right? That's where the midpoint should be. So let's do the math on it though. So one of these is x1, y1. The other one is x2, y2. Does not matter which one's which. Right, the midpoint formula says we're going to add the x's, -1 plus 5 over 2. And then we're going to add the y's, -2 plus -8 over 2. Right, if you notice, I didn't even follow x1, y. I know add the x's, add the y's, divide by 2. So -1 plus 5, that gets me 4. Right, anytime they're different signs, you subtract. So each piece, anytime they're different signs, you subtract. 5 minus 1 is 4. 5 is a bigger number, so it's positive. Anytime they're the same signs, you add -2 and -8, you just get more negatives, -10. And then we start to divide by 2. So we're going to get 4 divided by 2 is 2. And -5 divided by 2 is, sorry, -10 divided by 2 is -5. I hate when my brain works too fast. So we get 2, -5. And let's see if that works. 2, -5 is right there, right? That looks like the midpoint to me. Now the next one's actually the opposite. Well, not the opposite. It's a different way of doing this. The midpoint of JK is M. The midpoint of JK is M -3, 6. So it actually gave us the midpoint to start off. So -3, 6 is the midpoint. And if J is 2, -2, so 2, -2, they want to know where K is, right? So based on this, oh, K is going to be off the board. It's going to be like over here somewhere, right? This is the midpoint. It's not going to be in here. That'll be the midpoint of these two. That's not what I want. I'm saying the K is the other edge of this line segment. So it's the same distance from here to over here. So it'll be around there. So how do I solve it? Well, let's put back our formula. M equals x1 plus x2 over 2, comma, y1 plus y2 over 2. And then plug in what we know, right? We know the midpoint is 3, -6. That's over here. 3, -3, and 6. And we know that J is 2, -2. So let's make this x1, y1. So 2 and -2. And we'll let K be xy like it says. So K is the other x and the other y. So let's rewrite this. So -3, 6 equals 2 plus x over 2, comma, -2 plus y over 2. So from here, what do I do? Is we separate it. We put the x's together. So I have space over here. So -3 equals 2 plus x over 2. And then we'll put the y's together. So 6 equals negative 2 plus y over 2. Right, so we separate it. Put the x together and put the y's together. And now we just have to solve these two separate problems. Now I might look at it and be like, oh, fractions? I don't want to deal with fractions. Well, we don't have to, right? Let's get rid of that fraction on there. So opposite of dividing is multiplying. So we're going to multiply both sides by 2 over 1. Let me move this guy down. I might need the space. And now these cancel out. We get negative 6 equals 2 plus x. And we're going to subtract off that 2 from both sides. X equals negative 8. Now we have to solve this in the exact same way, right? Let's get rid of that 2, so 2 over 1. These cancel. I get 12 equals negative 2 plus y. Then we're going to add 2 to both sides. So 14 equals y. So my midpoint is negative 8 and 14, which I don't have on here, but it'll be up there somewhere. All right, that would be like the midpoint of those two. Okay, so now we know midpoint, hopefully. Now let's talk about the distance formula and how we get it. So distance formula is just what it sounds like, or the distance is just how far apart are 2 points. So how are we going to find that out? Well, the trick is to make a triangle, a right triangle. And then what we could do is we could figure out how far apart these guys are, how far apart these guys are, and then we could do Pythagorean theorem. A squared plus b squared equals c squared. Good old Pythagoras. Never let me down. So we have that formula. Now, what are these? Well, this guy, if I told you this side here was 2 and this side was 6, and I ask you how far apart they are, you'd be like, oh, 6 minus 2 is 4. This is 4 apart. We're going to do the same thing with these variables here. So this is x2 minus x1. Right, that's all it is. You did 6 minus 2. It would do x2 minus x1. Same thing right here, right? It would be this value, y2, minus this value, y1. So that's how you get your y's. y2 minus y1. Right? And then we could substitute this all into the formula. So my a is x2 minus x1 squared plus my b squared would be y2 minus y1 squared. And my c is my distance, d squared. I might wonder why that put absolute values. When you talk about distance, it's always absolute value because you don't care if it's negative or positive. So I just put little absolute values there. Now to find the distance formula, I want the distance d, but right now it's squared, so we gotta get rid of it. So we're gonna do the square root of both sides. So these cancel out. I get square root of x2 minus x1 squared plus y2 minus y1 squared equals the distance formula d. I get rid of the absolute values because since you're squaring it doesn't really matter. You can always get a positive anyway. But that's how you get the distance formula. That's how we got this guy here. That's where it comes from. So again, we could just use it, but that's where it comes from. It just goes, you make a right triangle and you do Pythagorean theorem. But for now, let's use the formula and let's do it on this example here, right? If a is 3, 2, so right there, and b is -1, -1, right there, let's find AB. How far apart is this one? So we could go from here and use our points and plug into the formula. But I'm going to show you another way first. What you could do is a Pythagorean theorem. You can figure out how far apart these guys are. Like this is from -1 to 3, that'd be 4 apart. And then from here to here, that'd be 3 apart. And then we can just do Pythagorean theorem. A squared plus b squared equals c squared. Right? 4 squared plus 3 squared equals c squared. And then work our way to our answer. That's totally fair game. You can always do that if you want to. But most times you don't want to do that. Like that's easy enough, but most times you don't want to draw. You don't have a graph to draw. You don't want to draw a graph. It's too much work. So we're just going to use the formula. So let's go over how to use the formula. Right? So x1, y1, x2, y2. So we're going to substitute them in where we see them. Now, it does not matter which one you set as x1, y1 or x2, y2. You get the same answer either way. Swap it, doesn't matter. Okay, let's put the formula in. This is from the square root of, right, x2 minus x1 squared plus y2 minus y1 squared. A lot of people make this a negative for some reason. I don't understand it. It's a plus. Just follow the formula. Okay, let's substitute it in. So x2 is -1 minus x1. So remember, there's a minus there as part of the formula. And x1 in this case is 3. So I get -1 minus 3 squared, which we'll figure out in a second, plus y2 is -1 minus, right? There's a minus there by default, and y1 is 2. So I get -1 minus 2 squared. So when we get to here, right, this be good at subtracting. Since they're both the same sign, -1 minus 3 are both negatives, you just add them. So it's -4 squared plus -1 minus 2. They're both negative, so -3 squared. Square root. Now here's another thing a lot of people do. They'll just cancel out all the squares. Like, that's not the way this works, right? If this wasn't here and you just had this guy, then yeah, you're good. But since there's a plus sign, you cannot do that. You have to simplify this first. So we have to do this first. Then we can square root it. So this is going to be 16 plus 9. Again, it's not -9, it's not -16. When you square something, it's always positive. If you can put in your calculator, put the parentheses. So then you get this, and you get 25. The square root of 25 is 5. And that's how far apart these things are. That's the distance, and that's the video.